under basic solution. In our previous video, we have considered the neutral solution, the acidic solution, but the prerogative for today's video is the basic solution. Under the basic solution, you need to add hydroxyl and water during the process of balancing this equation. So, under the basic solution, I'm adding hydroxyl and water. Meanwhile, the exception to this rule, in basic solution or while balancing basic solution, there are during the time of the solution where you first balance under acidic solution before you continue with your basic solution. Meanwhile, for you to understand how to balance equations, redox equation under acidic solution, you need to visit our previous video for proper understanding of that problem and how to solve problem that is of that sort. Now, we're looking at this equation. We have potassium gives me potassium hydroxide. Now, what do I do to balance this equation? What I'm going to do is that I'm going to add 4 hydroxyl. If I add 4 hydroxyl to this side, what I'm going to have is 4 hydroxyl, 4 hydroxyl, 1 potassium, 1 potassium. Meanwhile, notice that I have a -4 charge over there. 4 times -1 is -4. I have a -1 charge. Now, what is the difference between -4 and -1? The difference between -4 and -1, if you press your calculator, is going to give me 3. Alright, now having done that, I will add the 3 electrons to the side that have the highest charge. -1 has a higher charge than -4 on the number line. So I'm going to have potassium plus 4 hydroxyl, which is going to give me potassium hydroxide plus 3 electrons. Let me call this equation 1. Now, you notice that I have a -4 charge over there, the left-hand side, -4 charge over here. Now, let's go to the next half-cell equation, which is tetraoxosulfate gives me sulfur. Now, you can see that we need to balance this next equation under acidic solution first before we continue with the basic solution. Now, I have to add 4H2O. Why I add 4H2O is so as to balance the oxygen. 4 times 1, that is 4. This is 4 oxygen. But there is also a problem. I have 8 hydrogen here. So what I'm going to add is that I will add 8 hydrogen to the left-hand side. And then, having done that, I'm now going to balance under the basic solution. If I add 8 hydroxyl, 8 of hydroxyl to this side, I will add 8 hydroxyl to this side. Now, if I've done that, what I'm going to have, 8 hydroxyl plus 8 molecule of hydrogen, I'm going to have 8 molecule of water, 8 H2O, which is going to give me sulfur, plus 4 H2O, plus 8 hydroxyl. Now, I can reduce this equation because I have water here, I have water molecule here. If I subtract 4H2O from both sides, 4H2O from both sides, notice that 4 will cancel 4. Now I'm going to have SO4 minus plus 8H2O. 4 minus 8. 4 minus 8, that is going to give me 8 minus 4. That is going to give me 4. 4H2O. Sulfur. This has cancelled out. 8 hydrogen. Now, let's look at the particles. I have 1 sulfur, 1 sulfur. 4 times 2, 8 hydrogen. 8 times 1, 8 hydrogen. Oxygen, 4 oxygen. 4 times 1, 4. 4 plus 4, that is 8. 8 times 1, that is 8. The oxygen, the particles, the element, the atoms are balanced. Now let's check for the ions. I have minus 1, that is minus 9. I have minus 1, that is minus 1. So that means that the charges are not balanced. What I'm going to find is that minus 1 minus 9 minus 1 minus 9 minus 9, that should be 9, not 8. Alright, because 8 from here, 1 from here. Let's use a calculator now. Minus 1 minus 9. And that is going to give me 8. Now I'm going to add this 8 electron to the side with the highest charge. Now the side with the highest charge is minus 1. So I'm adding 8 electron to this side plus tetrasulfate plus 4H2O is going to give me sulfur plus 8 hydroxyl. Now I'm going to check out for the ions. I have minus 8 minus 1 minus 9 minus 8 minus 1 minus 9. Now we can see that the elements and the particles and the ions and the atoms of the first and the second two half reactions is balanced. The next thing is to equalize the equation. How do we equalize the equation? How we equalize the equation is by finding the LCM between 8 and 3. To find the LCM between 8 and 3, I'm going to multiply equation 1 by 8 and multiply equation 2 by 3. Alright, if I've done that, I will have that in equation 1, 8 times 1 of the 8 times 1, that is 8 of those, 8 potassium. 8 times by 4, 8 times 4, that should be 32 hydroxyl. Then 8 times by this guy is going to give me 8 of those. Let me call this equation 4. Alright, now having done that, I'm going to pick up the next equation. 3 times by, before we do that, 8 times by 3, I have not put that. 8 times by 3, that is 24. 24 electron, equation 4 now. Alright, now the next thing is 3 times by 8, that is 24. 24 electron. 3 times by this guy, that will give me 3 of those. 3 times by this guy, that will give me 12 water. 3 times by this guy, that will give me 3 sulfur. 3 times by this guy, that will give me, let's use a calculator, 3 times 8. 3 times by 8, that will give me 24. So I have 24 hydroxyl. Let's call this equation 5. Now, having done that, you notice that the electrons will cancel. And notice that the electrons are going to cancel. And this electron will cancel out this electron. Now, let me write down my new equation. I'll write down everything I see on the right hand side and everything I see on the left hand side. Let me make a space for myself. So I have 8 potassium plus 32 hydroxyl plus 3 tetrasulfate plus 12 H2O. Now I have all this. Let me get to the right hand side. I have 8 potassium hydroxide plus 3 sulfur plus 24 hydroxyl. Now, I have an hydroxyl at the right hand side. I have an hydroxyl at the left hand side. That means I can reduce this equation. If I decide to subtract 24 hydroxyl from both sides, notice that hydroxyl will cancel hydroxyl. Now I have succeeded in reducing my equation. My new equation becomes 8 potassium plus 32 minus 24. 32 minus 24. That should give me 8. I have 8 hydroxyl plus 3SO4 minus plus 12H2O, okay, and then I'm going to have 8 potassium hydroxide plus 3 sulfur. Now, let's check whether the atoms of element, the ions, the particles are balanced. So what we're going to do is that this for the right hand side, this for the left hand side. In potassium, I have 8 potassium here. Potassium, I have 8 times 1, that is 8. For the oxygen, 8 times 1, that is 8. 3 times by 4, that is 12. Now 12, 3 times 4, that is 12 oxygen. 3 times 4, 12 oxygen, plus 8 here, plus 8 is going to give me 20, alright? 3 times 4, 12, plus 8 is 20. Then 20 plus 12 times by 1, that is 12, plus 12. So I have 32 oxygen at this side. So oxygen here, let's check out for the oxygen here. 8 times by 4, 8 times by 4, 8 times by 4, I have 32 oxygen. You can see that oxygen is also 32. Oxygen is balanced. Sulfur, sulfur, 3 times 1, that is 3. Sulfur, this is 3 sulfur. Sulfur is also 3. Now hydrogen. Hydrogen, 8 times 1, that is 8. 8 times 1, that is also 8. Now, you can notice that all the elements and the particles are balanced. Let's check for the charges. And the charges, we have 8 times 1, that is 8, minus 8 plus minus 3. The total charge here is minus 12. Minus 8, minus 3, let's minus 8 minus is minus 11. Okay, minus 11. Now let's check for the charge at this side. All right, at this side, maybe there's a mistake somewhere. This is minus 11. Over here, there's a charge here. Okay, we then bring down the charge. You can see the charge is there. So 8 times 1, that is 8, plus 3, that is also minus 11. All right, notice that this charge is coming from here. All right, so this is how to balance this kind of problem, or this type of problem under acidic solution. If you have watched this video to this point, thank you very much for your time, for your patience. We hope to help you more, and then we hope to help you to learn more of chemistry. And you can visit our other videos on neutral solution, on acidic solution, before you can properly understand the basic solution. Thank you very much for watching. See you in our next class.